this is how we studied, right? This is how we got the information in our head. This is how we memorized it. This is how we got it back out of our heads for an exam, right? So you go on a first date, and this is reviewing the nervous system, right? You use your eyes and you see this beautiful woman, right? And as soon as you see this beautiful woman, right? I realize this is very heterosexually oriented, but whatever. Just pretend that you like her and you're a guy, right? You see this beautiful woman, right? Your heart is going to begin to pound, right? And so you know this scenario, right? And so to study for the nervous system, and then you might do things like you might groom yourself, and you might try to look sexy, whatever, right? So this is a story, right? It's a silly story. It has 4 boxes, right? But it walks you through sensory input, right? You have integration in the brain somewhere. You have a motor output, right? And some of that motor output is going to be to the involuntary nervous system, and some of it's going to be to the voluntary nervous system, right? And then you can put on top of that, you have the peripheral nervous system, an afferent branch, right? Taking in that sensory input. You have the central nervous system integrating it. You have the peripheral nervous system, the efferent branch. You're doing these 2 things down here. And you have the involuntary and the voluntary, or the autonomic and the somatic, right? And in this case, you have the sympathetic and that's parasympathetic because you're getting excited and you're not trying to go to sleep, right? You don't see the love and relax and then contact. You get revved up. Okay, so you get sympathetic, not parasympathetic. Right? So that is just the way, that is how, if I was trying to memorize these things, right, that might be a story that I tell my buddy, or that we come up with on our own to get it into our head. Right? When we were learning, I forget what we were learning, there was something about peaches and all sorts of stuff. Right? It made no sense, it was very silly, but it got you through it. Okay? Alright. This is another way, so this is another example. This is again the central nervous system. Right? The central nervous system, you have these 2 things, you can make a map like this. The peripheral nervous system, you have motor division, you have the sensory division. If you don't remember, so efferent, the effectors, is going to cause an effect, right? If I get mad and I punch someone, the effect is that I punch them, right? And in order to punch them, I have to use my motor system, right? The afferent is the sensory input. And then off of both of the peripherals, right, we can have autonomic, we can have somatic, right, or involuntary, right? Does everyone sort of see what I'm trying to show you here? And I know you guys hopefully are pairing up with people and learning different ways to study. Because the one thing that I didn't tell you, or maybe I did tell you, right? Some of you are going to get through here, some of you are going to get into med school, and then once you get into med school, some of you aren't going to make it to the next stage, right? So learn, and the reason you're not going to get to the next stage is you're not going to have the skills to get you through it, right? So use your time now, learn the skills. There's probably 10 to 20% of this class that has mastered the skills. Find them and learn the skills, okay? I was a really bad writer. What did I do? I went to the writing center, right? I found people who wrote. I found English majors. I wrote. And I hated it, but I did it, right? And then I got better, right? Now I publish articles. I write book chapters, whatever, right? You can get over it. I still am not very good at it, right? But I learned the skill in order to get through it, okay? I have full confidence that all of you can learn the skill to study and master exams, right? Okay, and then one more division beyond that, right? Then you have sympathetic comparison. All right. And all of these things, right, they're all linked up with these nerves. Okay, these are all spinal nerves coming off. These are going to the parasympathetic, sympathetic. In case you never saw this picture before, right, it just sort of gives you an idea of all the different organs. Some organs are linked to both the sympathetic and the parasympathetic. Okay. All right. And then we already went through all this, right? You have the center where a lot of things are being filtered, right? You got the sort of higher order thought going on here. You got basal stuff going on down here in the dicephalon. You got balance over here. this is what we're doing. We got our central nervous system, we're integrating stuff, right? Everything's wired, right? Which one of these two things, so now we're going to do hormones, which one of these two things would be like the central nervous system? A telephone? An old style telephone, this is not a cell phone, right? This is something that's plugged into the wall, okay? Versus a radio. Or this could be your cell phone, a radio. Cell phone or radio. Right? Which one, if you were to guess, you get 50-50, right? Which one is like the central nervous system? And which one is going to be like hormone or the endocrine system? The phone is like the central nervous system, right? You have, it's all wired up, it's all plugged in, there's direct connections going from here to there, right? The radio, right? The radio is off somewhere in La La Land, and it's getting signals from who knows where, right? Your cell phone's getting signals from who knows where, okay? So I work with a woman who's a plant geneticist. Her sister was a brilliant nuclear physicist who worked out at Palo Alto, where Einstein and all those people work, right? If you're a nuclear physicist and you work at Palo Alto, you're kind of in the top of the top, right? This woman said to her sister, she said, well, I understand how the radio in the house works because it's plugged into the wall, and so it gets the radio signals through the plug. But how does the radio in the car work? Right? They both work the same way. They both receive radio signals, right? So they receive signals from outside and come in. So even the brightest of the brightest visible. All right, so here's all of your endocrine glands, right? They're spread out all over the body, right? You have some in your brain, you got some around your throat, you got some around the top of your heart, right? You got your liver, there's some in your stomach, you got your adrenal glands on top of your kidneys, right? You have your gonads, ovaries if you're a female, testicles if you're a male. Right? All of these things produce hormones. Some of those hormones can act in isolation and they can hit the target cell and carry out whatever they need to do. Some of them need to work with another hormone in order to achieve their goal. Some of them reverse the effects of another hormone. Right? So just because a hormone's released doesn't mean that that's what's going to happen. Just like the nervous system, right? Even though you're really excited about something you see or whatever, it doesn't mean that you're going to act on it. Right? There could be other things that suppress whatever you do. Okay? So there's all different ways that hormones can go around, right? Hormones can come from the blood and go out the surface, right? You can have a gland that secretes it, right? This is all basic stuff for you guys. All right, so then we have these three things here, right? You have autocrine signal, which means the hormone is produced by that organ, right? And that hormone then acts on that organ, right? So it's autocrine, meaning that it's acting on itself like an autobiography is a story about yourself. Right? You can have a paracrine signal, which means that a cell secretes the signal and stimulates a cell nearby. Right? So parallel lines, think of it as nearby. And then you can have full-on endocrine signals, right? Which means you have a secretion somewhere, you have a secretion in your brain, and that hormone goes into the bloodstream and then hits target organs wherever, right? You secrete testosterone, you secrete estrogen, right? That doesn't just have localized effects. It doesn't just affect your testes, it doesn't just affect your ovaries, right? Those are sort of global effects, right? That we can all relate to. Right? Does this all make sense to everyone? This is something that people have trouble with the first time through. Most of you, this is your second time through. Yes?
So some hormones can be both endocrine and autocrine?
You could be, yes, you could be a combination of these, and you could both affect yourself in something nearby, or you could affect yourself in something far away, or you could affect something nearby and far away. Yeah. You don't have to be just, you don't just have to be one thing. Like estrogen would be an example, right? So estrogen is important for the reproductive cycle, but it also sort of affects other things around the body. Any other questions? Okay. And so then there's 3 different ways that these can be used, right? They can be used in neural signals. So part of the signaling between neurons is sometimes hormonal. So when you go across that synaptic cleft, right, you're not sending a depolarizing signal anymore, right? You're sending a chemical across, and the chemical is going to be received, right? And therefore, it's that chemical signal or that hormonal signal is neuronal, right? So between neurons. You can have neuroendocrine where the neuron secretes that chemical, and instead of it affecting another neuron, right, it's going to go into the bloodstream and it's going to affect some target tissue somewhere else. And sometimes when spring's in the air, right, and Uri Beach is packed, right, you could have hormone signals, in this case it's called pheromones, right, being released by one animal, right, and affecting another animal. And I know you guys are all very mature and very sophisticated. Probably don't secrete pheromones, right? But you might put on cologne or perfume, right? Which is based off of pheromones. Right? You do produce pheromones. If you want to be above that, right? Pheromones are also colognes and perfumes. That's what they're based on, right? That's why there's all the different ones. That's why when you put it on, it interacts with your skin and gives off a certain smell. So if you wear, I don't know, Nautica cologne and I wear Nautica cologne, it's not going to smell the same way as yours. Right? And different people are going to find the different odors attractive. Right? Okay. All right. So we sort of went through this. We'll do it one more time, right? And so you can do the simple thing, right? You could do just a simple endocrine pathway. You have something that secretes something, it hits something else, goes into the bloodstream, hits something else, and get a response, right? You could have another one where it's neuroendocrine, right? And a neuron stimulates a neuron that stimulates the secretion of something, then it hits the target cell, and you get a response. Right? Does anyone know an example that follows this pathway? Yeah, dopamine's in there, but I was thinking even more general. There's an organ, it's in your brain. You're close. The pituitary, right? You have the anterior and posterior pituitary glands. Right? The signal between these two are sort of neural, right? And then the posterior secretes some sort of endocrine signal. It's not always how it works, but that's one way it works, right? So that's a real life example of this. Okay. Then you could also, in the same system, right, you could have the anterior stimulate the posterior, it releases something into the blood, which stimulates another endocrine organ to secrete something else, right, which then hits the target tissue. Okay? So again, this is all just sort of illustrating to you, right? And we can probably figure out something that does this. Okay? This is all just illustrating that you always think, or I may have always thought in the past, that endocrine signal is just as simple, like you have a signal and sent out, you reach something and something happens, right? But there's this complicated linkage that goes on, right? And at any point in that linkage, you could have something break down. Okay. Right. Questions about this stuff? Okay.
Question about what would be the stimulus for the endocrine cell alone?
This one?
Yeah.
you could just, I mean, it could just be estrogen. I mean, estrogen is an easy one, right? So estrogen, and we'll talk about this when we talk about the reproductive system. So estrogen and progesterone together, right, are going to stimulate a whole bunch of things that lead up to follicle-stimulating hormone and the release of an ova, right? But they're targeting the endometrial lining of the uterus, right, and having it proliferate and having it shed. Another one would be you could have some form of androgens, such as adrenaline, produced from the adrenal cortex of the adrenal glands on top of the kidney, right? And that's going to affect tissues across the body. Okay. And so this is just a really complicated picture, so this is really basic stuff you've probably seen before. But because some of you are transfer students, I'm trying to give you what maybe you didn't have. So there's polypeptides and peptides, right? There are these long chains of stuff, right? They can hit a receptor because it's not lipid soluble, right? It has to bind on the receptor on the outside of the cell, and then that receptor somehow interacts with that target cell to make things happen, right? You could also similarly have an amino acid do exactly the same thing, and again, because it's not lipid soluble, it has to bind to a receptor, and then that receptor does something downstream. And then the last one that can go through is a steroid. So this is fat soluble. So it can go through the phospholipid bilayer and directly stimulate a receptor inside. Okay. So two of these have to hit a receptor on the outside and then turn something on the inside. And the steroid is the one that can cross. Any questions about this stuff? Okay. So this is basically giving you details. Do not memorize these details, right? So here's an amino acid, right? Epinephrine, which is one of the things in the previous slide. That is a receptor, right? That receptor then goes to activate this G protein here, right, which interacts with this protein over here, right? And that takes ATP, makes it into this. And you go through this whole chain reaction here, so you finally end up with production of glucose and glycogen, right? A long pathway, right? So in this pathway, right, do you think the only place we could shut this down would be up here, so we could put some sort of blocker, we could outcompete for this receptor site, right? We could do something else, we could knock epinephrine out somehow. Or could we potentially shut this down anywhere along, shut down here, shut down there? Where could things go wrong? Anywhere, right? At any point, we could shut this down, right? This is what a lot of molecular biologists are doing. That's how they figure out what these cycles are, right? They knock something out, they see that the product isn't produced after that, and then they know, okay, there's another step, right? This isn't the last step. So then they figure out how to knock the next thing out and the next thing out until they figure it all out, right? Sometimes they just go to the top, bottom down, and top. All right. But you can knock this out at any point, right? You can keep directly for here, or you can knock something out later on. So, is that. All right, so steroids going to come in, right? It's going to bind to something. That is going to then go and it's going to attach onto, usually it's going to attach onto your DNA, right? And you're going to synthesize something. So in terms of these two things, right, comparing epinephrine or the steroid hormone, right, which one would have more amplification? The amplification would be, right, if I tell you that I'm going to increase your score 5-fold, or I'm going to increase your score 100-fold, right, both of those are amplification. 100-fold would be bigger, right? So which one of these has a higher amplification? Yes. The steroid, right? Because the steroid, you have one thing coming in, right? It's going to attach. You're going to have more than one thing coming in, but you have, in this example, you have one thing coming in, attaches here, and then it's going to make a whole bunch of mRNA, right? It's just going to keep cycling until the signal gets shut down. It's going to make all of these proteins, right? So it's basically turning on a factory, right? Whereas in this example, you have that one thing coming on, right? And you're ending up with one product at the end. Right? Does that make sense to everyone? Okay. And then you can have the same thing. So in this case, you have epinephrine, right? Epinephrine can bind to different receptors. It can bind to the same receptor on different cells and have different results, or it can bind on the same sort of cell to different receptors and have different results. So, for instance, some wacky doctor when I was in high school decided that he would let me have a vial of Valium. And I was taking this Valium and I was injecting it into goldfish and looking at normal response in goldfish. And we went and talked to some professors at Rutgers, and the guys at Rutgers said, all right, so your Valium is going to attach to a GABA receptor, and that GABA receptor can have an alpha or a beta, right? You guys probably know if you take Valium, right, the known effect of Valium is a suppressant, right? It makes you slow down, right? And that's the case if it attaches to an alpha receptor. In rare cases, it attaches to a beta receptor, and it's like taking speed, right? It ramps you up and you don't go down, okay? Which is the complete opposite effect of what a doctor wants to do when he gives you Valium, right? So same drug, two polarly opposite effects, right? Depending on which receptor it hits. Same receptor, same hormone, right? In this case, the epinephrine hits the beta receptor, makes this glycogen deposits, right? It breaks it down, makes glucose. In a blood vessel, right, it causes the blood vessel to dilate. The blood vessel doesn't have glycogen deposits, it's not going to do all this stuff. Right? It's just going to increase the blood flow. Why do you think what do you think the link between those two things is? So you're making something that your body's going to use, right, as a substrate. You're making ATP, right? And here you're increasing blood flow. What is the link between those two items, right? Is it just random, like your body just produces epinephrine and it just so happens that if it hits different target cells? What's that? More cellulites?
More solutes are going to be in blood, right?
More solutes in the blood? You're close. So what do you associate with increased blood flow? So if you're in the parasympathetic or the sympathetic nervous system, right? Which one of those two is going to increase blood flow? Well, I guess it depends on what you're doing, yeah.
Wait, you said fluid?
Why would you, if you're in, so pick a system, you're either in the sympathetic or the parasympathetic nervous system, right? You're either in fight or flight, right? So pick either fight or pick flight. Why would your vessels dilate? To get more oxygen, right? And so if you have more oxygen, you need more oxygen because? Yeah, so they can do the action they need, which means that they're increasing their metabolism, right? Their energy requirement is going up, and so where is that energy going to come from? It's going to come from ATP, which you need this glucose to produce, right? And so that's the link between those two, right? You guys, does everyone understand that? So if I'm putting together a test question, that's how I would come up with a test question, right? I would look at a figure like this and I'd be like, oh, this is interesting. Why are these two things linked? Let me figure out a scenario to ask me about. Okay? I'm trying to help you, but this is all about trying to help you. So if you don't understand it, ask me, and I'll try to help you do it. Okay. And then this totally makes sense, right? So if you want to turn on, in this case, right, so this is an intestinal blood vessel, and this is a skeletal blood vessel, right? So this means in this scenario, well, maybe it doesn't make sense. I'll retract that. So in this scenario, you're also in the involuntary nervous system, right? Are you in fight? Or are you in rest and relax, or are you in fight and flight? For B and C. So B, right, the skeletal muscles, blood vessels are dilating, right? And the intestinal blood vessels are constricting. Are you rest and relax or fight and flight? Fight and flight, right? Because your skeletal muscles are making you run away, right? So you need, their metabolism's going up. So you need more blood flow there. Your intestinal blood vessels are constricting, right? Because you can't have everything open. And right now, you're not wanting to eat, right? You want to get out of wherever you are, right? You may even vomit up your food to lighten your load, right? You're getting out of there, okay? Does everyone see how we pulled more content out of this slide, out of this picture? Okay. All right. So these are other silly things that I would do, right? So these are the different ways that your hormones can work. You can have permissiveness, right? Which means that one hormone needs the approval of another hormone in order to carry out its action, right? You can have synergism, and I tried to pick the most ridiculous cartoons, okay, so these get burned into your mind, okay? You have synergism where two hormones work together to carry out a given task, right? Just like synergistic muscles, right? Or you can have antagonism, similar to antagonistic muscles, right? Where one hormone is resisting, or an arm muscle, one hormone is resisting the effects of another hormone, and in antagonism with hormones, it can actually reverse the effect of that hormone. And I went with some pictures up here and said this happening. Any questions about these three different ways hormones can have effects? All right. So I'll just show you a slide of frogs. Right, someone asked me about what does the thyroid gland do, and I totally blew it. Right, the thyroid gland produces T3 and T4. Right, it has nothing to do with parathyroid. T4 is an inactive form, T3 is an active form, and T3 is involved in upregulating metabolism and getting things to grow. Okay? There is ionization, but that is not linked to parathyroid gland. So T3 is basically going to make this tadpole go from being a tadpole to being a tadpole-ish frog with legs, right, to being a full-grown frog. Yeah, so T3 would hopefully go back to T4 and be inactive, that's right. I mean, you still want to have, you still probably want to have some T3 around. So T3 is going to be involved in regulating, it's not just going to be part of growing, but it's going to be regulating metabolism. So let's say this frog is in a pond where there's not a whole lot of things that want to eat it, right? T3 might shut down, right? It's just sort of sitting around. It finds some food, finds someone that it wants to have babies with, right? And it's just sitting around, right? And that's all it does, right? If that frog all of a sudden moved to another pond where a lot of blue herons came in to like eat frogs, right? This frog's life has now become a lot more complicated, right? And it's going to be eating a lot more food, it's going to be swimming around a whole lot more, right? And so T3 might come back on in that case to increase its metabolism and make it competitive and possibly survive longer. All right. So this is a disease of your thyroid gland. Okay. So Graves' disease. I don't know who this actress is. You guys probably know. All right. This is some famous actress. Who? It's a singer? Oh, okay. It's a famous singer. And so she has Graves' disease, right? This is, and I gave you this one. It's not as good of a picture as this one, but just so that it has some contemporary relevance. Right? This is a picture of a woman also with Graves' disease. It sort of looks like a goiter, but it's not really. It could turn into a goiter if this was untreated. Right? But you can see there's swelling, right? She has extra skin, right? Sometimes the eyes bulge out. Right? And this is a disease of hypothyroidism. Right? So remember, the thyroid is producing T3 or T4. Right? So hypothyroidism. So if things are normal, it's not hypo or hyper. Right? So what would hyperthyroidism be? Too much, right? So hypo is too little, right? So the metabolism is being lowered. Now we have a lower metabolism because of the thyroid being out of whack, right? So what then, why does she look like this and she look like this? And why might their eyes look more bulgy? Right? All of you saw a brain last week, had an eye attached to it. Right? You may have not recognized it as an eye. Right? What was all around that eye? Fat, right? So if you're hypothyroidism, right, what about the fat